Actual energy performance certificates, originally created more than 10 years ago, are enough to rate buildings, but most of them represent a basic evaluation systems.
The existing energy performance certificate is a tool which provides information about the overall building energy performance. However, there is room for improvement in order to be more reliable and user-friendly.
The current EPC insufficiently incorporates real-life user patterns, actual climate conditions, and smart and novel technologies. As a result, there is a gap between the theoretical and the actual energy performance, and also a lack of accuracy.
And another challenge of the current EPC schemes is that they are not comparable among European member states.
Member states develop their own assessment methods, giving rise to the lack of convergence across the European Union.
On the one hand, it is necessary to homogenize the calculation mechanisms among all member states so as to promote a single market and a greater offer of services.
And additionally, new technology developments such as smart buildings, electric vehicles, storage, self-consumption, etc. need to be integrated into our existing EPC schemes.
But also, it seems that some stakeholders are interested in bringing more dynamics in the tool, by e.g. including measured operational data, such as consumptions and occupancy in the calculation, and updating the EPC more frequently.
Finally, all previous challenges imply a lack of trust in the market regarding EPCs and the difficulty to access financial support for building renovation based on this assessment.
So the existing energy performance certificates are not sufficient to rate a building's energy performance because they are not really used or accepted by end users.
Panacea arises to meet the need for evolution of current building energy evaluation based on the knowledge and experience of European companies and organizations that have joined.
Next generation of EPCs needs a next generation of web-based tools and their innovative capabilities.
The SEPAP is our smart energy performance assessment online platform, which allows us to test the Panacea methodology with 3 assessment methods and real case studies. So it's quite a innovative tool which uses artificial intelligence, machine learning, and it will be able to self-calibrate over time.
Here too, measurement data are incorporated by means of advanced statistical methods and dynamical simulations.
SEPAP is a development that reflects the vision of an energy evaluation mechanism for buildings adapted to current future needs. It's a platform that meets the requirements that have been detected through the analysis that carried out by the Panacea project.
I think one of the benefits of the new improved calculation method developed in IPANASA project will be ability to provide better advice and recommendation for the end user regarding how and in which order his or her property could be improved to achieve better energy efficiency.
Apart from APC, there are other new and very promising tools, such as the Building Innovation Passport and the Digital Building Logbook. These tools can also help in achieving energy efficiency in existing buildings and also contribute to reaching the EU Innovation Wave goals.
Including EPC data in accessible digital building logbooks can promote the creation of new market opportunities. The Smart Gridness Indicator, or SRI, provides information on the building gridness to communicate with the occupants, optimize energy use, and interact with the energy grids. In IPANASEA, we explore potential synergies between current EPCs and SRI to facilitate the transition towards smarter and more sustainable buildings.
Based on measured data and calibrated models, IPANASEA project integrates tailored recommendations and renovation roadmaps based on actual energy use and global costs according to the cost-optimal methodology.
This would support the role of EPC as a tool to improve operational efficiency, energy management of the buildings, and to promote renovation by better justifying the recommendations.
That could improve and expand the criteria to determine what actions should be undertaken in a building to optimize the cost-benefit of the buildings in Europe.
ePanacea suggests an harmonized economic and viability analysis based on energy saving estimation for being integrated within EPC schemes, which could improve market trust on EPCs and mobilize investment in energy efficiency based on energy renovations of existing buildings.
The ePanacea approach is tested with 15 real case studies in our pilot countries, Austria, Belgium, Finland, Greece and Spain, and in close cooperation with building owners and building managers.
And the Testing and Demonstration Board, through the assessment of the case studies in the 5 pilot countries, will validate the methodology from a technical perspective in terms of accuracy and cost effectiveness.
We aim to establish a fluent dialogue with different European stakeholders, with special focus on national and regional policymakers, but also certification bodies, stakeholders of different industry, consumer associations, etc.
Yeah, so through the inclusion of end users, we already ensure that the ePanacea methodology later has practical relevance.
As a simple homeowner, ePanacea will help me understand in a better way, with simple graphs and figures, the energy performance of my house, how much energy I use, and what measures I can undertake to make my home more energy efficient.
Panacea will facilitate and complement the information that an energy certificate currently provides to the homeowner through standardized data and useful information in order to select the best measures for a possible rehabilitation of the building.